The main topic today is going to be just common modeling topics. These are going to be going over some frequently asked questions and tips that we have for those things. So what we're going to be going through is starting with creating transit platforms. Um, this is a fairly common thing that people are doing in Viswalk, and they have some questions about it, especially when it pertains to having multiple lines servicing the transit platform with different populations of people that need to board one line or the other. So that's kind of what we'll be looking at today, starting with, and then we'll be moving into configuring queuing areas. There are different ways that you can configure queuing areas, and what we're going to be discussing mostly is going to be service point selection queuing areas. So talking about something like a security checkpoint or a ticketing concourse or something like that. And then we'll be getting into a little bit of calibrating walking behaviors, especially um, with shelter in place orders and social distancing going on. People have been wanting to have been asking a lot about how do we calibrate our walking behaviors in general, as well as for increasing social distancing and things like that. And so we'll be talking about the social force model a little bit, and then we have a calibration worksheet that we could go through. And then as a bonus topic, we've had a few questions about leading pedestrian intervals in the RBC in recent weeks, so I figured I'd throw that in as well. So you guys are getting a little bit of bonus content today. Okay, so let's start with modeling transit platforms. Again, we're going to be talking about focusing on the main objects and some tips and tricks on how to model those in a efficient way. So in Vissim and Viswalk, this is where the mesh point really is between the vehicular network and the pedestrian network that we have, is at the platform level. So for us, internally in Viswalk, we call everything a platform and a waiting area, but this doesn't necessarily have to be a platform and a waiting area. You can think of this as a curbside or anywhere where you have some sort of public transit vehicle arriving at a predefined stop and then a population of passengers waiting to board or alight from that position. The key objects for creating a platform are the public transit stop on an adjacent link. There is an area that you'll be building called a platform area. This is kind of seen as the edge of the platform. So in the image here, you see, that yellow stripe. This is the actual point where people will be boarding or alighting from the vehicle. We have the waiting area on the platform. This is just the general area where people are standing around waiting for the vehicle to arrive. And then you need two sets of routes. You need some routes leading in from external areas to the waiting area, where the waiting area is the destination of those routes. And then you need a static route leading away from the platform edge, where passengers that are alighting will pick up a route to know where to go afterwards. So we're going to start with some tips about creating the public transit stop itself. There are a lot of different ways to create a public transit stop, but there are some things you should do that will help prevent errors or make your life a little bit easier in the long run. And so the first tip is make sure that the leading edge of the transit stop is where you want the vehicle to actually stop on the network. So your platform may be much longer than the actual vehicle itself, and the leading edge of the public transit stop is where it will actually come to a complete stop. If you're looking at something like a subway, there might be one vehicle per transit stop, but if you're looking at something like a bus bay, there may be 3 or 4 vehicles that can stack onto the same stop. So the next tip is to ensure that the PT stop length is greater than that of the vehicles utilizing it. And we see that there could be multiple vehicles. So if you have 3 50-foot buses stacked on top of each other, you want to make sure that that stop is long enough for all 3 of them to occupy it at the same time. Now, if it is long enough to occupy multiple vehicles and they do stack up, pedestrians will board and alight from all the vehicles at the same time. Whereas if the stop is short enough for just the first vehicle, then the other vehicles that are stacked up behind it will wait to board and alight until they are actually onto the stop. So taking into account your vehicle length is big, and making sure that the public transit stop accounts for that. The next tip is pretty standard tip that I make for all VISM objects, is to name and number your object in a way that makes sense for you. A lot of times I see people using just the number that is generated automatically by VISM and just leaving the name blank. But this is your opportunity to place information into the network that would match your field conditions. So for example, the stop number, I'll frequently use the stop ID number that we find in the field so that I can match my data to my field data pretty easily. And on top of that, I will make sure to name the stop according with the line and street names as well, so that again, I can easily find it in my data sheet. And then lastly, if you have different lines with different boarding populations, then you can stack multiple public transit stops. So in our example that we'll be looking at, we have two westbound lines. One is the orange line and one is the blue line. And they have different passengers that want to board for each line. Some passengers want to take the blue line, some want to take the orange line. If that is the case, then you will need to place two different public transit stops and then push the train lines through each of their respective stops. And this is because when you get to the point of creating the waiting area is assigned to a specific public transit stop. And so you will be sending those populations of people to technically different waiting areas. So for that, you'll need two different public transit stops. Once you have your public transit stop, the next thing you're going to do is create the public transit platform. Technically, you could create the platform ahead of time, but in my experience, it's best if you go through creating the platform by using the context menu. So when you create the public transit stop, you'll then right click on it, or if you're using a different right click behavior, use control right click. It'll bring up the context menu and you'll see that option for add platform edge to the right. This will create a platform edge that is lined up where it needs to be with the public transit stop. It will also be of the correct length. Sometimes if the platform edge is too far away from the edge of the link, pedestrians won't board and alight properly. Similarly, if the platform edge is sometimes in a weird shape or too long or too short, it can cause odd behavior. So in my experience, it's best to create the public transit stop first, then right click on it and say add platform edge to the right. This will also save you some time because it'll automatically assign that pedestrian area to the correct stop. Another tip that I have is create a custom display type for platform edges. That way, or platform areas. That way, it's easy to discern them from the larger spaces. So you might have a large pedestrian area that's representing the whole platform space that people can occupy, but again, this platform area is usually just the mesh point between the Viswalk network and the VISM network. I also usually give it a little bit of an offset because in 3D, if you have two different display types, they can kind of flicker back and forth. So I usually give it, a 0.1 foot vertical offset above the other areas, so that way it shows up without the flickering. And then if you have done that stacking multiple public transit stops that we discussed in the previous slide, you don't need multiple platform edges. You can create just one and then assign it to both just fine, because this is where passengers are going to be alighting. So if you have multiple platform edges, then you would need multiple routes directing them out of the station. And so you can consolidate your efforts by creating just a single platform edge. Then once you've created the platform edge, you'll create your waiting areas. The key thing here is that the waiting area, the passengers that are waiting for the public transit vehicle to arrive will wait at random positions within the waiting area. So if you make the entire platform area the waiting area, then you could have people waiting in far corners of the space. And so usually what we'd recommend is that you use the geometry of the waiting area to kind of corral the people into the appropriate locations, especially if you have platforms with stops on either side with stops on either side of the platform. You might have waiting areas for the left side of the platform closer to the left side and waiting areas for the right side closer to the right side. So again, using that geometry to kind of corral people into the correct locations. As with uh, uh, platforms, I would recommend giving the waiting areas their own display types. So again, you can discern them easily between the two, between normal areas and platforms, as well as an offset, as I talked about before. Now, in this case, if you do have different lines with different boarding populations and you have stacked those public transit stops on top of each other, this is why you would do that stacking, is because if we look in the image here at number 4, you might have, an orange westbound line and a blue westbound line where certain people would get on the orange and certain people would get onto the blue. So in that case, you would navigate your Viswalk pedestrians to 2 different areas that are looking at a specific stop so that they only board one or the other. And now in this case, they can be stacked on top of each other. And then in that case, the social forces models will still take over and they'll still interact with each other. But technically, they will be observing the rules of different waiting areas. So here we offset them for exaggeration so you can easily see. But in a real model, you can literally stack them on top of each other. That should be fine. Next is the modeling of the static routes. So there's a few different ways that you can model the static routes. Here in a transit center in particular, here are some tips that we suggest that will make it a little bit easier for you. The first is to use a static route from the door to the platform edges with intermediate points in each zone. This can make it easier for when we talk about like security queues and things like this. Again, this isn't a hard set rule, but this will make it easier if you're using things like partial routes to use those partial routes, because those partial routes require intermediate points. Now, depending on your data, you might not be able to do this. You might have to do kind of a zone-to-zone static routing, which is fine. And then within each zone, we recommend using partial routes rather than using other static routes, just because the static route will control the major flows, and then the partial routes will control the intermediate activities that they have to do. At the platform area, you would navigate people to the general platform space, and then if you do have multiple waiting areas for different stops, then use a new static route to navigate people from the platform space, the larger area that represents the platform, to the individual waiting areas. And the reason we recommend this is because then you don't have to duplicate your overall static routes from the entry. You can have one major static route that goes from the entry to the general platforms that controls all pedestrians, and then you take the pedestrians by class and separate them out once they get to the platforms, because more or less their experience is going to be the same moving through the rest of the terminal. All right, so now we're going to get into just showing you a little bit in our example. We did a Farragut West model in Washington, D.C. It's controlled by the Washington Metro Transit Authority. And so we did a Viswalk model, and I just wanted to kind of show you how we set that up. So in 3D, this is kind of what it looks like. It's a multi-tier stop. So we have the street level and then escalators down to a mezzanine level where security and ticketing take place. If I activate my 3D objects, we can kind of see that. So we have our turnstiles here, and then they descend on escalators down to the main platform areas. So in Viswalk, how we modeled this is this is one of the examples where we had multiple stops. So we had a westbound, we had a blue line stop, and then we had an orange line stop as well. So in that case, we have two different lines running to it. We have just a single platform edge for each side of for each of the stops. And if I open up the editor for the platform edge under public transport, you can see that here its usage is defined as a platform edge, and it's flagged for the westbound blue stop and the westbound orange stop. So this is a list of all the available public transit stops. All right. Then from that area, we placed a static route that leads out of the network. So we have one route that is going to the east and one route that is going to the west exits. So this will grab anyone that's alighting from the vehicles and pull them out. Now, we didn't observe a significant number of transfers. This is in particular an AM model. So most of the time people are arriving in the city and then alighting out onto the street. But if you did have transfers, you'd also want a additional route that goes to the other platform or to the other waiting areas as well. Then we have the waiting areas themselves. Here we have two different waiting areas, one for the blue line and one for the orange line. You can kind of see the shape that we created because here is the larger platform space that we created that represents the actual square footage of the platform. But we don't want them to be waiting in all those little corners behind escalators and things like that. So we confined them to this region, which was the most common regions that we confined them to. Then we have routes navigating them from the mezzanine down to the general platform area, and then specific static routes that are flagged for specific pedestrians, westbound orange boarding pedestrians and westbound blue pedestrians, so that way they could be navigated to the correct area. Now let me just quickly run a simulation so you can kind of see what it looks like. So here we have the blue pedestrians waiting for blue trains. We have orange pedestrians waiting for orange trains. And then we have green pedestrians alighting from the vehicles themselves. And you can kind of see them stacked up. So if I pause and go into 3D mode, we see that the orange train arrived and only the orange passengers boarded the vehicle. And then the blue passengers are waiting specifically for a blue train. Okay, so that is modeling platforms.